Hello, everyone, and yeah, thanks so much for having me. Just waiting for the slides.
We need some elevator music. Only the Americans get that. Okay, there we go.
All right. Yeah. Hey, everyone, I'm here to talk about Stackr. So we're building a micro rollup framework that allows scaling Web 2 and Web 3 applications. So before we begin, everyone talks about like where the rollup is deployed, what exactly is a rollup, are rollups real or not? But I want to start with like why is a rollup? Like what is the purpose of rollup? Why are we even building rollups? So a little bit about me. So I'm the founder of Stackr, and so the first generation of blockchains, which was Bitcoin, focused mostly on settlement in terms of asset transfer. Then came in Ethereum, which added another layer on top of it, which added arbitrary execution. However, the problem with that was the execution and the settlement was a lot coupled, was very coupled together. So they formed monoliths, and that caused all the scaling problems. So one could not scale without the other, and all of the other things like it was not that we had a lot of demands when it was invented, but now that we are getting a lot of adoption with all of these things, we definitely need to think about it. So that's where like generation 3 blockchains came in, which goes under the concept of modularism, which is separating execution from settlement. And that is where rollups come in. So the purpose of rollups is to like separate the execution from the settlement so that the application scales and like works better. So there are a few rollup misconceptions. Because of the initial design that we saw over here, a lot of things like got into like how a rollup should be designed, wherein it shouldn't be like that. So a rollup needs to run a VM. So it's ironic that we are at VM Day and I'm talking about like we should not run a VM, but I'll prove the point later. So another thing is like the rollups need to be stateful. So rollups don't need to be that. So you can just like take in some inputs from L1 and then just do some stuff without actually even storing any state. And the other thing is like rollup needs to be a blockchain. That's also not true. So just to go over that, let's take an example of matrix multiplication. This is a seemingly simple compute, like you just like take in a bunch of numbers, you multiply them, and then add them together. However, this gets very complex as the size of matrices grow. So what happens is like it becomes very impractical to do it on chain. So what's the solution? So let's build a matrix multiplication rollup. So there are just 3 steps. You get all the inputs from L1. You just do the matrix multiplication off chain, and you just post results back on L1. And on top of that, you can just do like easy fraud proofs because re-execution is a thing. So you can just like re-execute all the data on chain, and you'll just do like a fraud proof to check if the matrix multiplication was right or not. Obviously, it's going to cost more, but that's what fraud proofs are. So what essentially is there that you get a full rollup, which is completely valid. There is no VM because we can do the computation anyhow. There is no state because the matrix multiplication rollup doesn't store anything, and there is no blockchain involved, obviously. So what does that mean? This is a valid rollup. So that's anyone can do this. Just take input from layer 1, just multiply some numbers on a calculator, and then post it back on post back the results. So rollups essentially become like a message passing bridge, wherein you just do computation and you just post that result back on layer 1. Yeah. So these are some characteristics which every rollup should have. So they should be flexible. That means they can just there should not be any constraint on input, output, or the state data. They should be deterministic. That every action should have like a deterministic outcome, and they should publish data on L1 so that the computation is verifiable. So what the heck are micro rollups? So that's what we are building. So what the heck are those? Before that, we need to understand what the hell are general purpose rollups. So for general purpose rollups, say run a general purpose VM. The VM has all the bells and whistles that you need to build any sort of application. That VM is shared by all the application, and the apps run inside the VM. Then came in application-specific VMs. So these are modified VMs which are responsible for handling a particular set of tasks and only implements a specific feature set, but the apps still run inside the VM. What it essentially does is they kind of follow some of the characteristics except flexibility. Because flexibility is something which these rollups cannot provide, and that's what is because you are constrained by the rules of the VM. So what's the solution? That's micro rollups. So the STF is the app logic itself. It's not that you are running a separate STF for running the application. You just implement the STF as the application logic itself. There are no constraints. They are fully modular because you can do whatever you want, and they're extremely lightweight so that you could run it on your mobile device or your browser window or whatever. So that's, yeah. So to define microloops, they are like standalone new execution environment. So I just love inventing terms. So new execution environments is a term which we just came up after microloops. And what they do is basically they do local execution and then they outsource verification to some other entity. So the application, instead of running inside a VM, the application becomes your VM or not a VM. So this is a basic micro rollup architecture. So the user, so the micro rollup splits it into two parts, which is the executor and the auditor. So the executor is responsible for just running the application logic. The user directly interacts with the application. It sends in requests and gets a response, which is immediate, because this is very similar to how Web 2 applications work. And then the executor takes up all the computation results and sends it to the auditor, along with how the results should be verified. So it takes in the results and a verification mechanism, sends it to the auditor. The auditor generates proof or attestation, so it can actually re-execute the data or just run it inside like a VM or like a RISC-0 VM or like whatever that. And it just posts that data on L1. So that's how a micro rollup looks like. Yeah. So if you remember this, then this is what micro rollups enable. So they can just run any kind of application, send it to the auditor, and then post it on L1. And this unlocks a new paradigm for different kinds of applications. You can build games, cloud services, social networks, supply chains, identity limits. So there is absolutely no limit. So the idea is like you can just progressively decentralize Web 2 applications and make them like decentralized. And that's where Stackr comes in, which is a framework, a toolkit, and a network all built into one. So it provides a framework to implement micro rollups. It provides all the necessary tooling to build micro rollups, and it provides a network of auditors that allows you to post data and sends it across. And this is how the Stackr framework is structured. So you have two layers. One is the execution layer, which has all the applications that run all the execution in their own runtime. Then we have the Vulkan layer, which is aptly named. So it does all the auditing and the verification. It also does proof generation, and it also helps in interoperability between the applications. So the term micro rollup was actually inspired by microservices. So each application can be thought of as a simple microservice, which kind of works together with other microservices or micro rollups to become like a larger application. And these are some of the features. So the application executes stuff in their own runtime. You can build custom state machines as your own app logic. They're completely lightweight. You can have plugins. So we don't enforce anything. You can have your own sequencing layer. You can have your own data availability layer. You can do whatever you want in the entire stack. And the most important thing is it helps in sufficient decentralization. So executors can actually be deployed as like centralized application, and this helps them to progressively decentralize their stacks. So the objective of Stackr is that while it can be used to build full rollups, it does not place the same emphasis on the highest level of security guarantees or permissionlessness. Instead, it enables halfway house level of security, which was also noted by Vitalik in his blog post, so that it helps like onboard a lot of Web 2 application into the Web 3 space. And yeah, we are excited to learn more about like different kind of use cases. So please hit us up. The developer preview of the SDK and white paper is coming soon. And you can use this email to reach out to us. Yep. Thank you.
Thank you. OK, do we have any questions?
This is pretty awesome. Yeah,
thanks.
So you mentioned that it doesn't, so micro rollups don't put an emphasis on the security aspect of things, right? So the first question is, what particular use cases do you see being for micro rollups? But also wanted to get your take a bit more on the differences in utility between a micro rollup and perhaps the quote-unquote L3s.
Yep. So like I said, like it's not that we don't put any emphasis on security. It's just that we post some emphasis on security. Like it's the case that it does not inherit the full security from L1, that you are running all the fraud-proof mechanism on L1. The verifier committee, which I mentioned, I think, okay, it stopped working. But yeah, the Vulkan layer which I showed up is the one which is responsible for verification. And it is the one which recomputes or like generates proof, and that's responsible for creating a sovereign system. So that's what I meant by security. And for the use cases, you can technically build like any kind of use case. So let's say, for example, you're building a game, and the game requires like a very high tick rate. So you can build the execution environment, which is very high throughput environment. And then once that session is over, you can actually demarcate the entire session into chunks of time, and you can just post like a 2-second data or like a 5-second data stream of stuff on chain. So that's how that's one of the use case that you can actually build.
So the plugins thing looked really cool, but this means that if I'm building the plugin, I also have to build a verifier for it, right?
Sorry, what?
If I build the plugin, I also have to build a verifier for it. Otherwise, it's like untrusted execution, right?
Yeah, so the plugins are actually like wrappers on top of the base environment. So the base environment itself is something which the verifiers can prove. So we are building a whole execution pipeline. So it takes your code, it divides it into like executable packets and then just run it through like a prover. And that's something which we're already building. So anything that is built on top of it is automatically like verifiable. So that's what we are doing.
So you have a VM.
Not at the execution side. Yeah.
So the auditors are actually doing quite a lot of work, I guess, in order to generate these proofs. So how is the fee market is going to look like for these auditors?
Yeah, so that's an interesting one because when we are thinking about it, since it's a hybrid sort of system, so it has components of Web 2 and Web 3 both. So we kind of divide the network into two parts. So the user and the application becomes one economy on their own, and the application and the auditor becomes an economy on their own. So the user and the application lies in the Web 2 sort of economy, and the application and the verifier comes in the Web 3 sort of economy. And that's where the fee market is there. So the committee, it's something which we're still like researching on what's the best optimal fee economy would look like. But yeah, that there would be some sort of like a fee market or like some sort of like a fee market. Yeah.
Okay, any other questions? Okay, if you can't tell, we're killing a little time because their speaker is on their way.